privacy enhancement technique that we spoke about, homomorphic encryption, a way to compute encrypted data. Welcome to my YouTube channel where you regularly see new content on data privacy. And as I mentioned, we are going to talk about homomorphic encryption in this video. The problem? Simple. You need to encrypt your data to keep it safe. A very basic thing is adopted for ages altogether. It picks up the data in transit, it can encrypt it. You store it somewhere at rest, it can encrypt it. And that's a very safe way of handling and keeping your data. But then, what about security? That's what encryption is doing, right? What about computing that data? So if I want to do anything on encrypted data, I need to decrypt it. Now, typically on a file server, the internal staff would have access and they don't need to decrypt it. Safe. But for example, if you have a backup and you want to do a recovery, you have to decrypt it. So that extra computation load, that extra time consumption is always there for decrypting it. Now, backup or such things are very small things and the load of decrypting may be very less. But the fact that you want to send the entire raw data, decrypted raw data for analysis somewhere makes it difficult to handle, right? So you don't want to get wasting resources on decrypting data and exposing the raw data to a third party. That can become a security threat. You have kept it encrypted, but when you are giving it for analysis, you are decrypting it, right? So you are losing the essence of keeping it secure. So homomorphic encryption comes in. It's a costly affair. It's not something that everyone would implement for everything, but it's a cryptographic method where you can perform mathematical operations on encrypted data. So you are able to work on the encrypted data, not get the data, but perform your analysis on the data so that you can get the output or the inference or the reports out of the data. Once you decrypt the data and you try and match the result that you got from homomorphic encryption versus from the raw data, you'll find that the results are accurate. So homomorphic encryption means you are calculating or computing encrypted data without the need of decryption. As a simple analogy, a chef uses a box of say ingredients pre-done ones. He is not looking into what all is there inside it, but he just picks up maybe a tablespoon, a teaspoon, whatever he wants to, and he uses it in making the meal, and the meal comes out to be perfect. That's where you are not into reading or getting into watching exactly how many grains of red chili were there and how many grains of turmeric were there, but you are able to utilize a teaspoon from there to cook the perfect food, and that's what you need, right? So if in case you are not using this box of ingredients, you might have bought 5 grams of red chili and 5 grams of turmeric to do it. That's the difference, right? So how it works? You encrypt the data with a public key. Encrypted data is sent for processing, and the processor performs operations on the ciphertext of encrypted data. Encrypted result is returned back to the user. The user looks at the results, uses them. Wants to check, he can decrypt the original data. Can he check? No, because then the homomorphic encryption base is gone. So you're not giving him the encrypted data with a key to decrypt. You are giving him a result to take care over analysis of the encrypted data, or you are giving him encrypted data to run the reports. That's it. Approaches. It could be a partial homomorphic encryption where you perform some functions and not all. Somewhat homomorphic encryption where you perform a limited sequence of operations, and full homomorphic encryption which supports any computation on encrypted data. Absolutely any kind of computation you want to do. Real world examples include healthcare where you analyze encrypted data. Third party sharing is there, even in finance for analysis of data. You don't want to share the data. Transactions, bank transactions, patient records. Patient healthcare information is sensitive, personally identifiable information. Cloud computing, AI and ML. So nowhere you want to give the real data, you give encrypted, homomorphically encrypted data so that only analysis can be done on that data. Benefits: the data is kept confidential. It is not exposed during computation. It enables you to preserve the privacy of the data and is compliant with all the regulators. Limitations: it's a heavy computational overhead, requires specialized cryptographic implementation, and it is not yet the mainstream in a production scale for AI. Why? It's a costly affair. Needs more resources in commercial terms also other than technical terms itself. So homomorphic encryption lets us compute encrypted data, closes the data in use gap, right? No decryption. It's ideal for regulated data collaboration in the future of secure privacy preserving AI and analytics. These are the key takeaways, key benefits of homomorphic encryption that you can see when you apply it to encrypted data. So, no exposure to real data, analyze the encrypted data and get the inference or the reports. Thank you for watching my video. If you like the content of the video, please press the bell and the like icon, subscribe to my YouTube channel and share your feedback in the comment section. Thank you.